So far we've looked at substances like metals that are gaining and losing electrons, but sometimes what's being reduced or oxidized is a gas. And how would that be set up in a half cell? Well, here is the hydrogen electrode, and we still need a surface where the solution, whatever ion is in the solution, can be in contact with the neutral form so that there can be a transfer of electrons. So what we do with a gas is that we have to use something for the electrode that is not reacting. And so we use platinum because it's not a very active metal, and so it doesn't participate in the reaction. And then you can see we have hydrogen gas coming in and bubbling against that surface where the electron transfer can take place, and the extra hydrogen is coming out. So along that surface we'll have hydrogen gas in contact with the surface where the electrons can come or go, depending on the reaction, through this wire that is attached to our plate. So this hydrogen electrode can be either the anode or the cathode, depending on what it's paired with. If we look at this reaction, which is this? Is this the anode or the cathode? So in this one, we see that the reactant is accepting electrons, so that's reduction. And we know that reduction occurs at the cathode. So this is a cathode. If we want to draw the line notation for this, we need to think about if it's going to be on the left or the right. And because it's the cathode, the notation for this half cell will be off to the right of wherever the double lines are. So I'm going to do the notation of this half cell right here. On the very end, on the right, that's where we have the terminal. And in this case, our terminal is this platinum. So on the very end, I'm going to put the platinum. And then I have a line because there's a phase boundary. And next to that, I have, remember that we always do this in order. This is reactant and product. So my product goes here. Phase boundary. And then I have my reactant, my hydrogen reactant there. So that is the line notation of this electrode. And if we're just doing the electrode, we really don't need that part. But anyway, let's look at another example. So here's an example that involves the hydrogen like we just saw. The first thing to do if we're going to do a line notation is to decide what's being reduced and what's being oxidized so that we can decide what's going to be on the left and what will be on the right. So if we look, we see that aluminum is going from neutral to positive. That means that it's losing electrons. And so that means that it's being oxidized. And we know that oxidation occurs at the anode. And we could do the same thing for the hydrogen. If we look, it's going from positive to being neutral. So it is gaining electrons. That's reduction. And that occurs at the cathode. Okay, on our line notation, you need to remember what goes on the left and what goes on the right. On the left, we always have the anode. So I'm going to start with my anode over here. I'm going to start with my terminal, which it is, in this case, it is just the reactant because it is a solid. So I'll just put aluminum that is a solid. Do a line for a phase boundary. Then I add my product. So I'm looking at this half reaction. Aluminum goes to +3. Notice that I don't use my coefficients in here. I just put the substances. Okay, and so there's that half reaction. Then I have what represents my salt bridge, the double lines, and then I go to my other reaction. I'm just going to switch colors so we can follow it. But again, my reactant goes first. Phase boundary, my product. And then, since this is a gas, I need to put my platinum terminal, and you'll use, platinum is the default for when you have a gas. So just to point out some things on this. So platinum is the terminal. Remember that this is the cathode. This electrode, this is an electrode. This is the terminal of the cathode. Just to remind you of some terminology, this is the anode electrode. Anyway, and so there you have it, anode and cathode cell line notation.